Hello students, welcome to Math and Magic. For this video, we are going to solve 3 challenging problems from different math competitions in the Philippines. This is for junior high school level. For item number 4, solve for x in 6 raised to quantity 3x minus 4 times 2 raised to quantity 2x plus 3 equals 648 times quantity 48 raised to x. Now, when given this kind of problem, we typically rewrite the base number in terms of product of its primes so that it is easier to find patterns and to solve. Doing that in this equation, for 6 we have base of 2 times 3 raised to 3x minus 4. Since 2 is already a prime number, we will just copy it. Equals, for 648, that is a product of 2 cubed times 3 raised to 4. For 48, we have 2 raised to 4 times 3. Then applying laws of exponent, power of a power, 2 now will have an exponent of 3x minus 4. 3 has an exponent of 3x minus 4 times 2 raised to 2x plus 3 will be equal to 2 cubed times 3 raised to 4 times 2 raised to 4x times 3 raised to x. By product of powers, 2 has an exponent of quantity 3x minus 4 plus quantity 2x plus 3 times 3 with exponent of 3x minus 4. That is equal to 2 raised to quantity 4x plus 3 times 3 raised to quantity x plus 4. Combining the exponent of 2 in the right side of the equation, we will have 2 raised to 5x minus 1. Since the bases are the same, you may now choose whether you will equate the exponents of 2 or 3. Both will yield to the same value for x. If we are going to take 2, that would be 5x minus 1 will be equal to 4x plus 3. Transposing positive 4x to the left side of the equation, we will have 5x minus 4x be equal to 3. Transpose negative 1 to the right side, that will become positive 1. 5x minus 4x is x, that is equal to 3 plus 1 or 4. The value of x for this item is 4. For 3, that would be the same. 3x minus 4 be equal to x plus 4. Transpose x to the left side, that would be 3x minus x be equal to 4. Negative 4 will now become positive 4. So we have 2x be equal to 8. Dividing both sides by 2, x is equal to 4. For item number 5, a point is selected inside rectangle ABCD such that the distance from the vertex is 11 centimeters. Its distance from the opposite vertex is 12 centimeters, and its distance from a third vertex is 3 centimeters. Question is, find its distance from the remaining vertex. Illustrating this problem, we have rectangle ABCD. Let point P be inside the rectangle such that the distance from A is 11 centimeters. From opposite vertex, which is C, to P has a distance of 12 centimeters. And from point D is 3 centimeters. Question is, how far is point P to point B? Or simply, how long is line segment BP? First, we assume that A, B, C, and D be distances of P to the sides AB, CD, AD, and BC respectively. By Pythagorean theorem, we will have the following equations. A squared plus C squared be equal to 11 squared. B squared plus C squared be equal to 3 squared. B squared plus D squared, that is 12 squared. And A squared plus D squared, which is equal to BP squared. Since we are looking for the length of BP, we will use the last Pythagorean equation. BP squared will be equal to A squared plus D squared. Next, rewrite the first Pythagorean equation in terms of A squared, the third Pythagorean equation in terms of D squared, and then substitute to this equation. It will now become BP squared be equal to A squared is the same as 11 squared minus C squared. D squared is the same as 12 squared minus B squared. Notice in the right side of this equation that we can factor negative 1 to negative C squared and negative B squared so that it will become positive B squared plus C squared. Equation is BP squared equals 11 squared plus 12 squared minus quantity B squared plus C squared. Notice that b squared plus c squared based on the second Pythagorean equation is the same as 3 squared. So we can substitute 3 squared to that binomial. Equation now will become 11 squared plus 12 squared minus 3 squared. 11 squared is 121. 12 squared is 144. 3 squared is 9. Performing the operation, we have 256. That is the same as BP squared. Now getting the square root of both sides of the equation, BP now is equal to 16 centimeters. Hence, the distance of point P to the remaining vertex of the rectangle is 16 centimeters. For item number 6, evaluate the cube root of square root of 32 times the fourth root of cube root of 32 times the fifth root of the fourth root of 32 times and so on and so forth up to the 10th root of 9th root of 32. First, we need to rewrite these radicals in terms of their prime bases and expressing all the roots in fractional exponent. Cube root of square root of 32 will now become quantity 2 raised to 5 raised to 1/2 times 1/3. Fourth root of cube root of 32 will be 2 raised to 5 raised to 1/3 times 1/4 and so on and so forth up to 2 raised to 5 raised to 1 over 9 times 1 over 10. Applying product of power rule, since all of the bases are the same, that is 2 raised to 5, we can add the exponents. The resulting exponent now will become 1 over 2 times 3 plus 1 over 3 times 4 plus 1 over 4 times 5 plus and so on and so forth plus 1 over 9 times 10. Finding the structure for the exponent, say setting one of the denominator be equal to k, that would be 1 over k, and since the multiplier is 1 more than the multiplicand, we will have k plus 1. We need to find an equation that would satisfy 1 over k times k plus 1. Separating the denominators, we'll have 1 over k and 1 over k plus 1. Since the LCD is the same as k times k plus 1, divide that by k, we'll have k plus 1 times 1, that is k plus 1. Then for 1 over k plus 1, if we're going to divide the LCD by that binomial, we'll have k. The operation that we could use here is subtraction so that we could remove the variable. Hence, we will now have the original structure, which is 1 over k times k plus 1. Applying this formula to the exponents, we'll have 1/2 minus 1/3 plus 1/3 minus 1/4 plus 1/4 minus 1 over 5 plus and so on and so forth plus 1 over 9 minus 1 over 10. Notice that there are items that we could cancel out like 1/3, 1/4, 1/5 and so on and so forth. What remains now in this set of rational numbers are 1/2 minus 1 over 10. Performing the operation, we need to get the LCD first, that is 10. 10 divided by 2, that is 5 times 1 or 5. Then minus 1. 5 minus 1 is 4 over 10. Simplify the value. We'll have 2 over 5. Hence, the sum of the rational series for the exponent is 2/5. Setting that as the exponent of the base, 2 raised to 5, we will have quantity 2 raised to 5 raised to 2 over 5. Applying power of a power rule, we'll now have 2 squared or simply 4. Hence, the product of these radicals is positive 4. Thank you for watching. Please do not forget to like, share, and subscribe. God bless.